This is our AP Statistics final presentation by Rebecca, Amanda, and Breanna. Starting off is Chapter 1, Exploring Data.
We start off Chapter 1 by exploring the two different types of variables that you will encounter during data analysis. The first type of variable is a categorical variable, and they are variables that are placed into individual groups so they can only be depicted on bar graphs and pie graphs. Some examples of these are color, gender, and year. The other type of variable is a quantitative variable. It's not necessarily numeric, but they are measurable values, and they are depicted using stem plot graphs, histograms, scatter plots, and line graphs. Some examples of these are temperature, age, and height.
For the types of graphs, for stem plots, it's basically it gives a quick picture of the shape of a distribution while giving the actual numerical value in the graph, and it works better with smaller observations. Gives quantitative variables. It's also called a stem and leaf plot. Histograms, they break the range of values into classes and display only the count or percent of the observation that fall into each class. They work better with larger numbers of observations, and they also display quantitative variables. Bar graphs display categorical variables and compare any set of quantities that are measured in the same units. Pie charts are used when you want to display or emphasize each category's relation to the whole. And line graphs have points connected by lines to show how each variable changes in relation to each other. In Chapter 1, there are important terms through examining distributions. First off is outlier, which is the value falling outside the overall pattern. Midpoint has roughly half the observations with smaller values and half larger. Mode are the major common peaks. Unimodal, a distribution with one major peak. Symmetric is when the value is smaller than the midpoint, are mirror images. And then skewed is either right if it's a right tail, and longer than the left tail, which are the smaller values.
When examining data, it is important to describe the distribution using its shape, center, spread, and outliers. The shape of the data can fall into certain categories: skewed to the right or left, symmetric, or in modes, such as unimodal or bimodal. The center of the data varies based on its shape. If the data is skewed or has outliers, its center will be described by the median value or the middle value because it is unaffected by outliers. If the data is approximately normal, the center is described by the mean value, also known as the average value. As you can see in the picture in the top right, here's the formula to find the mean. You add the sum of all of the values from the distribution together and divide it by the total number of values in the distribution. The spread of the data is found based on the center that is being used to describe the data. If the mean is being used to describe the data, then the standard deviation is used to describe the spread. If the median is being used to describe the data, then the interquartile range, which is the value of quartile 3 minus the value of quartile 1, is used to describe the spread. The outliers of the data are also individually found based on how the center and spread are being measured. If the mean is used, then the outliers are any values found outside of 2 standard deviations from the mean. If the median is being used, then the outliers are determined using the IQR times 1.5 rule. In this rule, the IQR is multiplied by 1.5, and then that product is subtracted from quartile 1 and added to quartile 3, and any values that fall outside of this range are considered outliers.
The 5-number summary just displays the minimum, quartile 1, median, quartile 3, and maximum values. A box plot is just a graph of the 5-number summary, so the central box spans quartiles 1 and 3, and the line in the middle marks the median, and then the lines that extend out from the box go to the minimum and maximum values. The standard deviation and variance are also very important and work together. So standard deviation measures the spread by looking at how far observations are from the mean, which is also the square root of variance. And then variance is the average of the squares of the deviations of the observations from their mean and can be written as S squared. And in the pink box is the formula for sample standard deviation. For linear transformations, changes in the original variable x to x nu is given by the equation x nu equals a plus bx. When you add a constant a value, you shift all the values of x by the same amount. And when you multiply by a constant of b value, it changes the size of the unit of measurement. But this doesn't change the shape of a distribution, but center and spread may still change.